Hello, this video will introduce you to solving quadratic equations using the quadratic formula. We've previously talked about quadratic equations that can be solved by factoring. So, for example, solve 0 equals x minus 2 times x plus 5. Now, in this case, the equation is already in factored form, and so we can say that either the first factor, x minus 2, has to equal 0 in order for x minus 2 times x plus 5 to equal 0, or the second factor has to equal 0. And we solve each of those resulting equations to get x equals 2 and x equals negative 5 as our two solutions to this equation. So when the equation is already set up so that one side of the equation is 0 and the other side is in factored form, it's a very easy equation to solve. Sometimes we have to do the factoring. So here we have an equation that's quadratic where one side is 0 and we can see if we can factor the right-hand side. So we can try decomposition here. We want two numbers that multiply to 2 times 6, so multiply to 2 times 3, which is 6. And those two numbers have to add to negative 5, and those two numbers would be negative 2 and negative 3. And so we can rewrite this equation as 0 equals 2x squared minus 2x minus 3x. That replaces the negative 5x plus 3. And then common factor from the first two terms, so 2x times x minus 1. And common factor from the last two terms, so negative 3 times x minus 1. Now x minus 1 is in common, and we're left with 2x minus 3. So that's the factoring portion. But in order to fully solve the equation, of course, we then do what we did in the first example, where we set each of those two factors equal to 0 and solve. So here we get x is equal to 1 and x is equal to 3 over 2. So now the question is, what happens if we get an equation like this third one, 0 equals x squared minus 5x plus 3, where it's not factorable? We can't use this same strategy of solving by factoring if the equation is not factorable. Here, in order to factor this trinomial, we would need two numbers that multiply to 3 and add to negative 5. And those two numbers just don't exist. So what happens here? And this is where we're going to use the quadratic formula to solve the equation. So for quadratic equations that are of the form 0 equals ax squared plus bx plus c, we can solve that equation using this, which is known as the quadratic formula. So it's important to note that the quadratic equation that we're solving needs to have one side equal to 0. So if that's not the case, then you need to rearrange your equation so that one side is equal to 0. And then the other side of the equation, we're looking for a quadratic written in standard form, ax squared plus bx plus c. So you want to make sure your equation is set up that way first before you think about using quadratic formula. Once we're able to set up that equation and identify the values of a, b, and c, we can substitute those values of a, b, and c into this formula to figure out what are the x values equal to that will solve this equation. So the quadratic formula is x equals negative b plus or minus, that's going to give us two possible solutions, one with a plus sign to do the calculation and one with a minus sign to do the calculation. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So now let's go back to that question that we saw before. Solve 0 equals x squared minus 5x plus 3. Here we can identify the values of a, b, and c because the equation is already in this form where it's 0 equals a quadratic in standard form. So the value of a is the coefficient of x squared, which in this case, that's a 1. So a is equal to 1. B is the coefficient of x, which is negative 5. And c is the value of the constant, which in this case is positive 3. So we can use those values and substitute into quadratic formula because we already checked to make sure that this equation is not factorable. So we get x equals negative b, which is negative 5, plus or minus the square root of b squared, so negative 5 squared, minus 4 times a, which is 1, times c, which is 3. And all of that is divided by 2 times a, which is 1. Okay, so we simplify this a little bit. Negative 5, this is negative 1 times negative 5 is positive 5, so we can simplify that portion. Plus or minus the square root. Negative 5 squared is 25. And over here we have 4 times 1 times 3 is 12. So under the square root we have 25 minus 12, which works out to 13. And then divided by 2 times 1 is 2. At this point, this is as simplified as we can get without applying that plus and minus. So what we're going to do is split this up into our two possible solutions. So one of them is x equals 5 plus, so we're using the plus sign here, plus the square root of 13 divided by 2. And the other possible solution is using the subtraction sign, 5 minus the square root of 13 divided by 2. And this here is what we would call an exact answer. So these two that are listed here would be listed in exact form. So if a question asks you to solve a quadratic equation and leave your answers in exact form, you would leave your answers like this, or this is what your answers would look like before you would type them into a calculator. So that would be your exact form. If we type these each into our calculator, now you're going to get a decimal value. We're going to round these answers to the nearest tenth, so 1 decimal place. The first answer gives us approximately 4.3, and the second one gives us approximately 0.7. And these values that are rounded numbers after we punch them into our calculator give us what we call approximate solutions. So depending on instructions for a question, you may sometimes need to leave your answers as an exact value without using a calculator, or you could use your calculator to get approximate rounded values. Okay, so we have one more example here. In this case, our equation is not set up so that one side equals 0. So we want to do that first. So to get the right-hand side to be 0, I'm going to subtract 2 from both sides. So we get 5x squared minus 8x minus 2 is equal to 0. Okay. Then on the left-hand side, we can do a quick check to see if this is factorable or not. And in this case, we would need two numbers that multiply to negative 10 and add to negative 8. And we cannot find integers that fit that description. So this is not factorable, and so we will use the quadratic formula to solve for the values of x. So here we get x is equal to, and we want to identify what a, b, and c are. So in this case, a is 5, that's the coefficient of x squared. B is negative 8. And c is negative 2, the constant. Substituting those values into the quadratic formula, we get x equals negative b, so negative 8, plus or minus the square root of b squared, so negative 8 squared, minus 4ac, so minus 4 times 5 times negative 2, divided by 2 times a, which is 2 times 5. Okay, simplifying. Here again, negative 1 times negative 8 is positive 8, plus or minus the square root of, and we're going to get 64 plus, because we're going to have a negative 4 times and positive 5 times negative 2. So 64 plus 4 times 5 is 20, and times 2 is 40. So 64 plus 40. And then divide by 10. And so that is x equals 8 plus or minus the square root of 60 plus 40 is 100, plus 4, so 104 divided by 10. And again, we can split this up into our two possible solutions. So the first one being 8 plus the square root of 104 divided by 10. And the second one being x is 8 minus the square root of 104 divided by 10. And again, these are the exact value answers. If you need approximate answers, you would just type each of these separately into your calculator and round to the number of decimal places that are required for that question. So this gives us another way to solve quadratic equations in addition to solving by factoring that we did previously. Again, not all quadratic equations will be factorable, so this gives us an option to use when those quadratic equations are not factorable.